Lesson 1. Addition and subtraction of fractions. When adding or subtracting fractions, the first thing you need to do is make sure that the denominators, or the bottoms, are matching. Because here these are both 11ths. 5 11ths plus 2 11ths. Well, it's still out of 11ths. All we need to do is to add the numerators, or the tops. Or for subtracting, to subtract the numerators. 5 minus 2 is 3. The denominator is already matched. So there we go. Now, if the problems happen to not have matching denominators, for example, 1/3 plus 2/5, or perhaps 2/3 minus 1/8, now we need to make the denominators match. Now, if you're good with your multiples, you probably already know a number that's a multiple of both 3 and 5. One way you can check, if we're trying to find a multiple of 3 and 5, is you can check on the 3 row of your multiplication chart. There's a multiple of 5. On your 5 row, there's a multiple of 3. Notice? It's the same number in both of these. That's pretty good. It's the same number in both ones. There are other numbers that work. For example, 30 and 30 also would work as a combination. But right now we're going to stick with 15 because it happens to be the smallest. 3 times 5 is 15. So what I'm going to do is to multiply both the numerator and the denominator by 5. 5 times 3 is 15. So here, this side, I'm going to multiply both the numerator and the denominator by 3. What that has done is given me 5 15ths plus 6 15ths, and now they have the same denominator, which means I can just add the numerators together. 5 plus 6 is 11 15ths. And now I have my sum. For the subtraction, it's a similar process. Go ahead and take a moment to pause and see if you can find, using a multiplication chart, a multiple of 3 and 8, a number that's a multiple of both 3 and 8. Now that you've had a chance to look for that multiple, let me show you it on my list here. I looked at my 3's. Oh, there's the one that I know is a multiple of 8. Look at my 8's. I got 8, 16, 24. If I look here, maybe I don't want the 24's. Maybe I want a smaller one. We'll look through the list of rows. Do any of the numbers match? Nope, don't have a 16, don't have an 8. Okay, so 24 is where we go. 8 times 3 is 24. 3 times 8 is 24. So, multiply by 8, multiply by 8, multiply by 3, multiply by 3, and I get 2 times 8 is 16, 8 times 3 is 24, minus 1 times 3 is 3, 8 times 3 is 24. The difference of 16 and 3 is 13. 24ths. Alright. Now, a mixed number like 13 and 3/5 is basically the whole number 13 plus the fraction 3/5. So if I wanted to do something like adding 13 and 3/5 with 2 and 1/8, I would add the whole number parts, the 13 and the 2, 13 plus 2. And then I would add the fraction parts, the 3/5 plus 3/5 plus 1/8. I'm going to write my 13 and my 2 here in black because it seems to not be showing up on the video. The first part's easy. 13 plus 2, 15. Here I need to find common multiples. One trick, you might have noticed it before, is you can always just multiply the denominators together. 5 times 8 is 40. 8 times 5 is also 40. So now we have plus 24 40ths plus 5 40ths. The denominators match now. Add them together, 24 plus 5, and you get yourself 15 plus 29 40ths, which comes out to be a total of 15 and 29 40ths in a mixed number. All right. Now, to do the same kind of idea, but this time with subtraction, you may come across borrowing. Otherwise, it's exactly the same as subtracting with, or as adding with mixed numbers. If I have 13 and 3/5, subtract 2 and 7/8. Well, the whole number parts get subtracted. Okay. And we're also going to take the first fraction and subtract the second fraction from it. Notice how I'm still adding those together, because these two parts are from the same number up in the front. But you could totally think about it as two different ways. If like just, okay, maybe it's just two separate numbers, that's fine, and work at it that way. You may come across a problem with negatives, or you may have to borrow from the 13 to be able to subtract the 7/8 away. I'm going to leave the 13 and the 2 alone for now. I'm going to focus on the fractions. Notice it's 5 and 8 again, so we already know the denominator is 40. Hopefully you remember if I multiply the fifth side by 8, I get 24 40ths. Here, 5 times 7 is 35, and 8 times 5 is 40. Without using negatives, can I take 35 away from 24? No. What I end up needing to do is now I'm going to change that 13, because it was attached to that original 3/5, and I'm going to change it to 12. That 1 that just disappeared there really isn't going to disappear, because really that's 40 40ths that I can add to the 24 40ths. (40 plus 24, 64 40ths, minus 35 40ths. Now that's a subtraction I can do. 12 minus 2 is 10. All right. 64 minus 35. 60 minus 30 is 34. It's 34 minus 5 more to get us to 29. So our final answer is 10 and 29 40ths. Hey, that's almost the same answer that we had before. Interesting. All right, and that's how you subtract with mixed numbers where you have to borrow. You just borrow a whole 1. That 1 that's getting pulled down from right here is going into that 40 over 40. One last thing before we go. This drawing right here is called a line segment. The idea being, instead of being a line that goes out forever, it's got a special length to it. It's just a segment of the line, a piece of the line. Could go on out forever this way, but we just want this stuff between points A and point C. And the way we say this written down is we just write AC. If we want to show that it's a line segment, we can draw a line over the top. If we wanted to give it an actual length, like let's say AC is 10 1/4 inches long. Go ahead and just write it without the bar on the top. That lets us know that it's a length measurement now. Okay. I'm going to add in another point here. Point B. Now we still have this original line segment AC. Now we have two smaller sections, AB and BC. Let's say AB is 4 3/7 inches. The question is, how long is line segment BC from here to here? AB is the section between the two. AC is the whole length. If I want to know how far BC is, all I have to do is cut it off. Cutting off is the same operation as subtraction. 10 1/4 minus 4 3/7. So we find our subtraction. First thing I'm going to do is I'm going to get some common denominators here. I got 10 7/28 minus 4 12/28. Oh, look at that. I don't need to have enough. I need to borrow. So I'll go ahead and borrow from the 10 and change that to a 9. Add 28 in there, and I get myself 35/28 minus 4 12/28. Zoom out a little bit for you here so you can see the rest of it. 9 minus 4 is 5. 35 minus 12 is 23/28. That's how long line segment BC is.